Derivative! Spins!
Come on, Dora. Derivative. Derivative.
Let's go!
Dora, derivative. Calculus!
Calculus!
Spins is super cool and so is derivative.
Need your help!
Grab your backpack. Let's go. Jump in. Vamonos. You can calculus.
Hey!
Derivative. Sucker, no sucking. Oh man. Dora, the mathematician.
Hola! Soy Dora!
And I'm Boots.
As you can see, my friend Boots is sick. We have to go to the hospital right away. Can you help us get to the hospital? Great! Let's go! It's the grumpy old troll.
You cannot pass this bridge, Doravatives, my Boots. You know the rules. Get out of here. I'm the grumpy old troll who lives under the bridge. Hey, I'm the grumpy old troll who lives under the bridge. Who's there? If you wanna come over, all you have to do is this. Solve my riddle. The only way to pass is to solve this derivative. Y equals 2x squared. What is y prime?
Can you solve the derivative? Great, so can I. Let's do it together. So we know that the equation given is f of x is equal to 2x squared. To find the derivative, we can use the power rule. What this means is that f prime of x, the derivative of x, is equal to the coefficient of the term, which is 2, multiplied by the exponent of the x, which is also 2, multiplied by x to the power of the original exponent minus 1. In this case, that will end up being 4x to the first power. Therefore, the answer is 4x. Great job, everyone!
Dang it, you solved my riddle, Dora and Boots. You may now pass.
Hola! Soy Dora! And I fell into a ditch that's quickly filling with water. I know that the cylindrical pool has a radius of 10 feet and I'm 2 feet tall. I also know that the pool is filling up at a rate of 600 pi cubic feet per minute. How much time do I have to get out? Okay, so let's take a look. We know that the shape that we're dealing with here is a cylinder with a radius of 10 feet and a height of 2 feet. And it's quickly filling at the rate of 600 pi feet per minute. These are our given values. With these values, we need to find the rate of the water level's height in the pool, which means we need to know the volume equation, which is V is equal to the height times pi r squared. From here, we need to relate the height and the radius. In this case, we know that the height is 1/5 of the radius, which means r is equal to 5h. This is then plugged into the original equation to get 25 pi h cubed. Using the power rule, we can find the derivative, which is 75 pi h squared h prime. The h prime is added due to deriving multiple variables. We can then plug in our known values of the height and the rate of change of the volume to get 600 pi is equal to 300 pi h prime. If we solve for h prime, the rate of change of h, we get 2 feet per minute. With the rate of change, we can now figure out how much time I have to get out. The rate of change of h is equivalent to the height over time. If we reorganize this, we can get h over h prime is equal to time. With this, we plug in what we know and cancel out what needs to be canceled out, which leaves us with 1 minute to get out.
Cough, cough. Great job, everyone. All we need to do now is get out of the pool before the minute is up. Let's go! Vamonos!
You're too late! Ha ha ha! I have placed an unfinished cylindrical shell of 2 functions to block the entrance to the doctor's office. The only way to remove the shell is to complete the problem by finding the volume of the solid of revolution.
No! Swiper won't be able to stop us. Say it with me. Swiper, no integrating. Swiper, no integrating. Swiper, no integrating.
Aw, man!
Great job, everyone! Muy bien! Now let's get to the doctor's office. Bien hecho! We made it to lo hospital! Can you say lo hospital? Great job! Now let's practice using lo hospital's rule. Okay, so let's say we have the limit of x goes to 0 of sine of x over x. If we just plug in x, we'll get 0 over 0, which is undefined. Therefore, this limit is invalid. This makes it a candidate for L'Hopital's rule. To use L'Hopital's rule, you must take the derivative of the top equation and bottom equation in the limit. In this case, the derivative of sine is cosine, and the derivative of x is 1. This leaves you with the limit of x to 0 of cosine of x over 1. If you plug 0 into this equation, you get 1 over 1, which is 1. And that is the answer to the limit. Great job, everyone! Now we can go to the hospital and get Boots help! Yay, we did it!